So, welcome back to part 2 of this video. We're going to talk through a worked example. Now, try and keep those definitions in front of you so you can refer to them as we go through. So, every FTE cycle is started by the value in the program counter. Now, because RAM starts at location 1, the value in the program counter at this point is 1. That value is then copied to the MAR, so the MAR knows what address to go to. Now, at this point, the program counter is incremented. Now what that means is the value is increased by 1. So we set that program counter value to 2 and then we leave it alone for a bit. So coming back to the MAR, we know we need to go to address number 1. Now the contents from that address location need to be copied into the MDR, so we put LDA 8. Now we then need to split it into the instruction, which is LDA, which stands for load. It's a low-level language instruction for load, and the data is 8. So anything like load or save come before an address. So we know the address is 8, so we need to go back to the MAR and copy that address in. The MAR would then go to location number 8 in RAM, and the data, the contents, would be copied into the MDR. Now those contents are the number 12, so we update the MDR with the value 12. Because we're going to do some processing with this number, the value is loaded into the accumulator. Let's move on to the next step. So, from the last slide, the program counter was at the value 2. That value is copied into the MAR, so we know what address we're going to access. Before we go any further, again, we have to increment the program counter to the value 3. Now, coming back to the MAR, we need to go to address number 2 and get the contents, which is sub number 3, and we need to put that into the MDR. Now, because it's not load or save, we know we don't need to go back to RAM for any information, so we can decode. Now, sub is the low-level language for subtract. That should be 3. Subtract the number 3. Now, we had the value 12 in the accumulator from the last slide. So, we need to sub 3 from 12. So, that subtraction would occur in the arithmetic and logic unit, and then the results of that processing would be stored in the accumulator. So we need to update that value to 9, because 12 take 3 is 9. So the final step is the program counter is the value number 3. We need to copy that instruction to the MAR. Again, we increment that program counter. So that will be 4. It would be worth at this point just copying the value from the last slide into the accumulator of 9. So we've incremented our program counter. So we go to location number 3 as stated by the MAR, and we get the contents, which is STO11. STO is the low-level language for store. So it must be an address, so it wants us to store at number 11. So whatever is in the accumulator needs to be stored in location 11. So we go to location 11, and the data that's going to get written into there is that value of 9. That is an example of how all the registers are used within the CPU. Now there's quite a lot to take in there. Please rewatch this video as many times as you need to fully understand what's happening. Now, at this point, the best thing for you to do is have a go yourself. You can do it using a diagram like this, or if you want something a little more visual with the definitions, you could get a piece of paper, make some boxes with your definitions in, and follow the data through. Okay, you can change the data within RAM if you want, or you can use the same values that I've used. Don't worry if your piece of paper ends up looking like this. This means you're on the right track because there is a huge flow of data. And here we've also included the units. Okay, so you can see exactly what's happening. Like I said, please rewatch this video a few times, have your definitions in front of you and make sure you're really confident with where all the data is moving between. Once you've done that, there are some questions to finish. So pause your video at this point, have a go at the questions. When you're finished, unpause the video as I'll put the answers on shortly. So your 4 questions today are: what is the purpose of the CPU? Question 2, what are the What are the 2 major components of the CPU and what is the purpose of each? Number 3, what is a register? And question 4, can you name 4 registers in the CPU? I'm going to move on to the answers now, so if you haven't paused the video yet, do so now. So, let's go through the answers. The purpose of the CPU is to fetch, decode and execute the instructions stored in memory. Remember, we talked about this in the previous video. There are other definitions that would also get you the marks, such as processes all the data instructions. The 2 major units within the CPU are the ALU and the control unit. We know the ALU carries out the arithmetic and logic instructions, whereas the control unit coordinates the CPU activities. A register is a special fast memory location within the CPU. And the 4 registers that we've talked about in this video are the PC, the MAR, the MDR and the accumulator.